Alright, in this video, we're going to go over quadratic functions and transformations, part 2. Alright, problem 4. Using vertex form, what is the graph of f of x equals negative quantity x minus 1 squared plus 3? Well, let's figure this out. There's a few steps we need to look at here. So step 1, let's identify our constraints. Okay, let's identify the constraints. And remember, vertex form is y equals a x minus h squared plus k. All right, so let's find a, let's find h, and let's find k. A, remember, it's the number outside the parentheses that's multiplied to the parentheses, so here it's negative 2. H is the number in the parentheses with the x, and remember, you want to take the opposite sign that's in there. So since we have minus 1, h is a positive 1. And then k is simply the number added or subtracted to the end, and you take it as is. So here we have positive 3. So one more thing we need to look at is up here, since a is less than 0, since a is less than 0, we know our parabola opens downward. Right, it opens down. All right, step 2, plot the vertex. All right. All right, so the vertex, we know the vertex is hk. All right, vertex we know is h comma k. So in this case, we know it's 1 comma 3 because we already found h and k. So we're going to plot the vertex over 1, up 3. So there's our vertex. All right. Now, the next thing we're going to do is draw the axis of symmetry. All right, so step 2, plot vertex and draw axis of symmetry, AOS. So there's our vertex, and we know our axis of symmetry, it's going to be x equals h. So our axis of symmetry is going to be x equals 1. All right, so draw axis of symmetry. A little wobbly there, but that's okay. So that's step 2. Step 3, we need to plot a few more points. All right, we need to plot a few more points. So let's make an XY chart. All right, we already have our vertex. All right, so let's put in 0. Wow, sometimes this thing does weird things. All right, let's put in a 0. If we put in 0 into here, this is negative 1 squared times negative 2 plus 3, which comes out to be 1. And if we put in a 2, I'm sorry. If we put in a 2, we get 2 minus 1 squared times negative 2 plus 3 is also, I'm putting it at the wrong place. It's supposed to be 1, not 2. Sorry about that. So here we go. Here's 1. Here's the other. And then if we put in 2, what do we get there? So we get, so negative 2, parentheses, all right, so we put in a 0, and we got negative, and we got positive 1. All right, and we know it mirrors on the other side of the axis of symmetry, so we can just copy 1 over. Now let's put in negative 1 and see what we get. If you plug in negative 1, you should get out negative 5. So negative 1, 1, 2, 3, 4, 5. We know this mirrors over the axis of symmetry, so we can just, so once we find 1 point, we can just simply mirror it over the axis of symmetry, and then we can draw in our parabola. Hopefully yours looks a little better than mine. All right, so there is our parabola. So there's a So there's a little bit of a process when you're using vertex form. First thing you want to do is identify your constraints, A, H, and K. And then pay attention to A, because if A is less than 0, it opens down. If A is greater than 0, it opens up. All right, in our case, it opens down because A is less than 0. Your vertex, remember, is H comma K. So in this case, our vertex is 1, 3. All right, so we plotted 1, 3 first. Then draw in your axis of symmetry. Remember, your axis of symmetry will be x equals h. Okay, this will always be x equals h. For your axis of symmetry, we drew that in. Now, we really only need to get 2 points on this side because we know those points are mirrored to the other side. So we put in 0 and we got out 1. We put in -1, got out -5. And then we just simply mirrored those across our axis of symmetry. Then you connect all the points using a smooth curve. All right, you connect all the points using a smooth curve. All right. So I got one I want you to try. It says, what steps transform the graph from y equals x squared to y equals 2 parentheses x plus 2 squared minus 5. All right, so go ahead and figure that out. All right, so what transforms it? Well, first let's identify A, H, and K. For this one, you didn't have to graph it. We're just identifying the steps. So we know A is 2. All right, we know H is -2, and we know K is -5. All right, so we know since A is greater than 0, we know it opens up. All right, we know it opens up. And we know that this 2, since it's greater than 1, we know that this is also a vertical stretch by a factor of 2. All right, we know that the A there, since it's greater than 1, is a vertical stretch by a factor of 2. Okay. We also know, because of this +2 here, we know that this went to the left 2 units, and this -5 here, we know it went down 5 units. All right, so we know the 2, vertical stretch by a factor of 2, and we know since A is greater than 0, it still opens up, so that didn't change anything. This x plus 2, this +2 here, moves it to the left 2 units, and then this -5 on the end moves it down 5 units. All right, so hopefully you got that. It's pretty easy. All right. Writing a quadratic function in vertex form. Now, this is not as hard as it sounds. It takes a little bit of work, but it's not as hard as it sounds. All right, the picture shows the jump of a dolphin. What quadratic function models the path of the dolphin's jump? So we're going to take and we're going to write an equation for this red line right here. All right, we're going to write an equation for this red line. So the first thing we need to do, step 1, is we need to identify the vertex. All right, we need to identify the vertex. So if we look, it's about right here, looks like, and that is 3, 7. All right, so we have our vertex, 3, 7. All right, so we know H is +3, and we know K is +7. So now, what we're going to do is we're going to plug that into vertex form. Remember, vertex form is A parentheses x minus h squared plus k. So f of x equals a x minus 3 squared plus 7. Now, we're not done yet because we still have to solve for A. How do we solve for A? Well, you pick another point along this graph, all right, that this red line goes through. So if we look, it goes through this point right here. That point is 9, comma 4. All right, that point is 9, comma 4. So step 2, you identify another point on the graph. You identify another point on the graph, and we found that 9, 4 is another point that is on the graph. All right, so now what do we do? Well, we take 9 and 4, we know this is x and y, and we plug it up into here, into our equation that we just started for x and y. So we know f of x is another term for y, so we're going to have 4 equals a, parentheses, 9 minus 3 squared plus 7. All right, that's what we're going to do. So let's go ahead and now we have to solve for a. All right, now we have to solve for a. So 9 minus 3 is 6. So this is a times 6 squared plus 7 equals 4. 4 equals 36a plus 7. I come up here, subtract the 7 from both sides. So we have negative 3 equals 36a. And now we're going to divide both sides by 36. So a equals negative 3 over 36. We can pull a 3 out of both of these. So this goes to negative 1. This goes to 12. So we know that a equals negative 1 over 12. Okay, let me rewrite that. So we know that a equals negative 1 over 12. So now we can finish our equation from up here. We know the equation for this dolphin's jump is going to be f of x equals a, which is negative 1/12, parentheses, x minus 3 squared plus 7. All right, so how did we do that? Let's review. First thing we did, we identified the vertex. So we looked on here, we found the highest point. Since this opens down, if it would have opened up, we would have found the lowest point. All right, so we found the vertex. We identified the vertex, which is 3, 7. So we know h is 3 and k is 7. So then we took our vertex form, which is f of x or y, you can call it either one, y or f of x, equals a, parentheses, x minus h squared plus k. Then, since we know h and k already, 3, 7, we went ahead and plugged those in. F of x equals a, parentheses, x minus 3 squared plus 7. All we did was plug in h and k. Now, we still have to solve for a. So in order to start solving for a, we had to identify another point on this graph. So we're looking around, we're looking around, we're looking around, boom, right here. All right, right there. There's another point on the graph. All right, you could have picked anything. You could have picked this one, but you would have had to estimate it. So just pick one where your line goes exactly through an intersection of two of these. Okay, so we found that, 9, 4. All right, so we identified another point on the graph, 9, 4. So then what we did is, since we have our vertex form, which is f of x equals this, and we have our partial equation, we put in 9 for the x, and then 4 for the f of x or the y. And that's what we did right here. 4 equals a, parentheses, 9 minus 3 squared plus 7, and then we simply solved for a. So 9 minus 3 is 6. 6 squared is 36, so we have 36a plus 7 equals 4. We subtracted the 7 from both sides to get negative 3 equals 36a. Divided both sides by 36 to get a equals negative 3 over 36. We factored out a 3 from both the top and the bottom. The negative 3 becomes negative 1. The 36 becomes 12. So a is now negative 1 over 12. And now we look back up here at this equation, and all we needed was a. Now we found a, so you just simply take the negative 1/12 and plug it in for a. So our function is f of x equals negative 1/12 parentheses x minus 3 squared plus 7. If you notice, the only difference between this equation and the one we started up here is we now have the value for a filled in. Everything else stays the same as what we found up here. The only difference is now that we found a, we fill in the value for a. Okay? So that's it for the second part of quadratic functions and transformations. You know, writing an equation in vertex form from a graph, and also using vertex form to graph an equation. All right. So make sure you understand the concepts in this video. Feel free to watch it as many times as you need to, and see you tomorrow ready to work some problems.